Welcome to The Explainer. Today, we're diving into a pretty epic showdown between a giant of linguistics and a team of AI researchers. And it all boils down to one massive question. Can a machine really understand language the way we do? So the first shot was fired by the legendary linguist Noam Chomsky. He and his co-authors made this incredibly bold claim that large language models are, and I quote, incapable of distinguishing the possible from the impossible. What he's saying is that an LLM could learn a totally nonsensical, humanly impossible language just as easily as it could learn, say, English. Now, if that's true, it basically means LLMs are just fancy parrots and can't teach us a single thing about how human language actually works. But here's the catch. This huge claim was made with almost no experimental evidence to back it up. So you know what happened next? A team of scientists decided, okay, let's put that to the test. And that's what we're digging into today. We're looking at a paper that not only took on this challenge head-on, but also won a Best Paper Award at the huge ACL conference in 2024 for how they did it. Their mission, should they choose to accept it, was to make a language model learn the impossible. So here's the core of the challenge, right? If Chomsky's right, and an AI learns a language made of pure nonsense just as well as it learns a real human language, well then these models aren't really learning anything deep. They're just incredible mimics without any real grasp of the underlying rules that make our languages so special. So how in the world do you even test something like this? Well, first, you have to build something that's genuinely impossible for a human to learn naturally. The researchers' solution was super clever. They decided to systematically create a bunch of synthetic artificial languages, where each one was specifically designed to break a fundamental rule of how human languages are known to work. They came up with three main families of these impossible languages. First, you have shuffle languages, which just completely scramble the word order. Then there are reverse languages, which, you guessed it, flip entire sentences backwards. And finally, you've got hop languages, which use this bizarre count-based grammar that you just don't see in any human language on Earth. Let's start with the shuffle languages, because they're wild. In the most extreme version, the model was fed sentences where the words were just thrown into a blender. So a perfectly normal sentence like, he cleans his very messy books, becomes a totally jumbled mess of words. There's just no structure left at all. So why is this so hard for anyone or any AI to learn? It's because it violates a really deep principle called information locality. See, in any normal language, words that are related, like an adjective and the noun it's describing, they like to stick together. They're usually close. Randomly shuffling everything completely shatters that essential property. Okay, next up, the hop languages. This is where they got really creative with grammar. You know how in English we add an S to a verb, like he cleans? The researchers replaced that with a special marker, an S. In the normal version, it's right where you'd expect it, after the verb. But in the impossible version, they made that S hop to a totally arbitrary spot, like exactly 4 words later. And this is the whole point, right? This is just not how human language works, at all. We don't mark grammar by just counting 1, 2, 3, 4. Okay, put the S here. Our rules are built on structure, on things like noun phrases and verb phrases, not just random counting. All right, so with these bizarre, impossible languages all designed and ready, it was time to put an AI through its paces. Let's get into the experiment itself and see how they trained a GPT-2 model for this very strange mission. And the process here was incredibly careful. They started with a dataset that's about the size of what a small child might hear. Then, they basically created these alternate linguistic universes for each impossible language. For every single one of these universes, they trained a totally fresh GPT-2 model from the ground up. And to make absolutely sure the results weren't some random fluke, they did this whole thing 5 separate times for each language. So, after all that meticulous training, it was finally time for the moment of truth. Did the models learn the impossible just as easily as the possible? Was Chomsky right? Well, let me tell you, the results were anything but ambiguous. And boom, here are the results. They measured something called perplexity, which you can basically think of as the model's confusion level. A lower score means the model is less confused. It's getting the patterns. And the chart makes it obvious. The models trained on the normal, natural-like languages were way less confused than the ones trained on the impossible, jumbled-up versions. It wasn't even close. And when they drilled down into those weird count-based hop languages, the results got even more interesting. They measured how surprised the model was when a grammar marker went missing. And check this out.
The model trained on the natural rule was way more surprised when the marker wasn't where it should be. That tells you it had learned a much stronger, more confident pattern.
So no matter how you sliced it, the pattern was crystal clear. The models learning the natural languages had lower confusion, they actually learned faster, and they built up much stronger expectations about grammar. The evidence was all pointing in one very clear direction. And for the grand finale, they did something that sounds like science fiction. Using a technique called causal abstraction, they were basically able to perform a kind of brain surgery on the AI to see how it was solving these problems internally. And this just confirmed everything else. The model was building more robust, more efficient internal circuits for the natural rules. Okay, so after all of that, what's the big takeaway? How does this incredible experiment actually change the whole debate about AI and its relationship to human language? Well, for starters, it means one very big, very absolute claim about what large language models can and can't do has just been hit with some serious, repeatable, experimental evidence. The takeaways here are game-changing. First, contrary to Chomsky's claim, GPT-2 absolutely does distinguish between possible and impossible languages. It finds the natural ones way easier to learn. Second, this strongly suggests that these models have what's called an inductive bias, a sort of built-in preference for structures that look a lot like our own. And finally, and this might be the biggest deal of all, this opens a brand new door for science, using LLMs as a new kind of scientific instrument to explore the mysteries of language itself. Just as the authors themselves put it, instead of just dismissing these models, there's huge value in studying them as a comparative system. By figuring out what they find easy or hard, we can actually learn a ton about the deep principles that make our own languages work in the first place. And that really leaves us with a fascinating final thought. This research isn't just about debunking a claim about AI. It's deeper than that. By showing that an artificial system finds it easier to learn the kinds of patterns we humans use, it kind of forces us to ask, what are the fundamental principles that make our own languages so learnable? If even an AI learns our kind of language best, what does that teach us about us?